So, my session today is on data driven identities. So, I will just directly get into what the topic is about without any more assumptions. So, first part that yesterday when we were talking about, and in most of the sessions and also in the introduction that I tried to touch upon, is to understand that how this digital and the everyday is a socio-technical assemblage, right? It is neither purely technical nor purely social. So, when we talk about data, do you understand how is it different from information? What is the difference between information and data?
Information can be extracted from the data.
Information can be from the data. So, data made into information, okay.
Data is processed information.
Data,
Once information is processed.
data, okay. So, by that logic, data always precedes information. So, you see that as we proceed with these sort of definitions of these terms, data, information, right, you see that the vagueness of the terms, right, and the conflicting nature of these terms, that we use them, right, to mean different things, but when we actually have to define them, we really do not know what exactly the difference between the two, or where the data ends and the information starts, right. By that logic, if data precedes information, we are not really sure at what point it ceases to be data and it becomes information, right. So, now if we are looking, the question that I asked you, that try and think about data from like a time when there was no information technology, right, before ICTs. So, data, if I just put it in a very abstract or a very general sense, is basically quantification of the world, right. You are trying to classify and categorize what you see, right. And when you try and classify and categorize what you see, there is a certain meaning that you are attaching to these classificatory schemes, right. The one who is generating this data, let us say census data. So, there are categories on which I collect information from people, right. So, I ask what is your age, I ask what is your gender, I ask what is your educational qualifications. These for me are information about me, which I am giving to someone for them to fit it into this classificatory schema, right. And they have the meanings of these schemes clear in their mind for them to convert this information into data for their tables, right. So, the relationship between data and information is something which goes on in a loop, right. So, what is information for you might be data for someone, and what is data for someone might be information for you, right. Are you with me till here? Okay. So, now if we are talking about data is quantification in a very broader way, just feel free to stop me at any point, right, if you have any doubt. So, if you are talking about data as quantification of the world, right, you are trying to make sense of the world through some quantitative or very clear categories, right. Now, does it mean that it's a very purely technical thing, that when an information, so now we are moving from information towards talking about data, because that is the theme of our session. So, if you are talking about data in a quantified or in a categorized, classified manner, does it then become, so when we move from information to data, does it then become a very technical thing? So, then try and think about this axis that we were talking about yesterday, where the material is on the other side and the social on the other, right. So, this axis that we are talking about, so we first try and see how this data is both a material as well as a social thing, right. So, that is what we were trying to do in this session. So, the first segment of the talk, we are trying to look at what is the material aspect of data, right, and we are going to do it in terms of digital data. So, we are not looking at data which is pre-digital, we are trying to look at data which exists in the digital space, clear. And then the next part, which is the data driven identity. So, when we move on to identity, that's when we look at the social implications of data, or how data becomes a social thing as well, right. So, just to put thing in perspective is that what I am trying to do here is to map out the trajectory through which digital data has sort of traveled. So, these are not really exact timelines, I just tried to do it in a 10 years sort of a format. So, it is not like they are set in stone, right. So, the first stage is about when the computerization is taking place. So, there is certain kind of data that you are generating in digital space. Then from there you have network computer, so emails and stuff like that are starting, not emails so much, but shared computer network and the communication that exists within that. And from there, of course, the web and the internet and the email, so the different kinds of data that are getting generated. From that we are moving, which is sort of the scenario that we are all used to by now. This is something called mobile communications, which is basically looking at the data that is generated through mobile phones, communications, and then towards the end, with the advent of the smartphones, what we see, there's extremely connected devices, right. So, if you add the mobile communication with internet and the web, right, and everything that existed before that, so all these things are connected now. So, the amount of data that we are going to generate, can you imagine how much data we generate? Any idea? The kind of data that exists in the digital space now. Yeah, so I myself are not very clear about this terms like exabyte, petabytes, zettabytes, like who is bigger than whom kind of a thing. There is a greater than relation series that goes on, right. So, this is something, so in 10 years ago, humanity collectively generate about 5 exabytes of data per year, and you can see what is that exabyte. So, our files are usually, what we see when we are operating, it's megabytes or kilobytes, right. So, this is what the volume that we cannot even imagine, how the volume that we are talking about here. You can see the measurement of what exabytes basically these zettabytes. So, we are literally talking about zettabytes now, and so by 2015 we will have this much data, that is a prediction that we will have, and the darker one, right. So, why suddenly we have such a large volume of data? Who is producing this data?
We as a consumer.
As consumers, and so what's going to happen to all these data? Where do they stay? Data centers, okay. Anybody else? Where do they stay? I hear very soft murmurs. I need clearer voice.
Clouds.
Clouds, okay. Where are those clouds?
So,
Okay. So, you see, of course, you are right that with cloud we are seeing more and more percentage of the data that exists in the digital space is moving to cloud, right. We will come to what is cloud and how it operates in a bit, but this is the prediction by 2020. So, about 37 to 40% of our data that we generate on the digital space will be in the cloud. Now, what are these data that are getting generated? What kinds of data that we are talking about, right? So, this is of course again not exhaustive. This is just to give you a sense of the kind of data that are generated and that exist. So, first is of course the technology mediated interaction data that we generate on a daily basis when we use an app or a service online or through our mobile. Then of course social media data, which is our social networking sites, blogging, crowdsourced platforms, all these that we do on a daily basis in the digital, in any of the digital platforms, right. Then of course there is this IoT and sensor data, which are this RFID codes that are attached. So everybody understand what's IoT, Internet of Things is? I don't need to explain, no? Okay. So all these data now, this all of you know what this term, right, the big data, right. So this is what pretty much talking about when we are talking about big data, mostly the upper three sections of the data. Now of course there is this physical data, your bank account data, credit bureau, then we have biometric data which is travel informations, or like when you do immigration, cross border immigrations, or now something like an Aadhaar or any other biometric information that you have given. Demographic data would be something like a census, right. So all these data now, going back to the first slide, when we were looking at the the trajectory, right. So of course with computerizations and stuff like that, all these data has some point become digitized, right. Those were not like mediated through the technologies itself. So physical data are also now becoming digitized, and they are somehow getting all connected. That's what we are talking about, this exponential growth in the way we have connected devices, and because of that the volume of data that exists in the digital space now. Now in this kinds of data there are three types in thinking about it, data from a technical point of view. One is the structured data, semi-structured data and unstructured data. Anybody from CS background want to explain what are these? No?
For unstructured data, I can see social medicine for like indicators.
So these are unstructured data. This will be the unstructured data, right? So what would be a structured data? Proper levels. So where will this structured data, an example here would be? This one? Label data, okay.
In the gender, in the religion, in the caste.
Yes.
So we can basically categorize it. And some of it is like the unstructured data, we do not have labels to it. So this is like the, I would say the social media data.
Yes, so this one, okay. And the semi-structured?
Semi-structured is, we have like groups, we have some groups available, some like some we pass through some clustering algorithms so that we obtain some relation between them. That is like semi-structured.
Okay.
IoT is very structured or semi-structured depending on which where it's coming from.
Okay, so IoT could be both semi-structured and structured data. So people who do not come from CS background, do you understand now the difference between the three? If not, please raise your hand, because it's not so easy to understand.
So does it just mean like structured data is classified or labeled already?
Yes.
Media data which isn't organized.
It's not unorganized. So unstructured does not mean it is not organized. So I'll try and break it into more simple words. So structured data, so when we say structured data, we basically mean it as within a framework of a computational world, right? So a computational world would be what? Codes, programming languages and the algorithms, right? So with all this, what happens, the structured data is only machine readable, only machine readable. So if you look at this data without knowing the codes, you will not be able to, or knowing the language, you will not be able to understand, right? So only machine readable data from the computational point of view is called structured data, right? Now semi-structured data is something which is encoded in programming languages in a way that it with some markers and tags that it can be read by both the man and the machine, right. So this markup languages they have, right, you would extendable, something of that sort, right. Yeah, so this markup languages, the HTML would be one example of that, yeah. Yeah, then there is this, I think it's XTML, right? XML, yes. So all these languages, they are basically, these are markup languages which basically make it, this your web data, the digital data, they encode it in such a way that it is readable by the man and the machine in the same way, right? Now the unstructured data, that's where your social media data, that's where your all these app that you use, right, or the games that you play, stuff like that. So the things that we do on a daily basis on our, let's say on our smartphones, are unstructured data, because for it to be machine readable, it needs to be worked upon, right. The machine cannot immediately read it as of now.
So it's basically like the way it's codified from the point of view of the machine.
It is, it's not, that's what I said, it's not unorganized. So of course when you are doing all these things, there is a logic the way it will be structured, but in the computational world this would be something like a raw data that comes, which needs to be worked upon, right? Clear?
But biometrics, even man can understand, like human can understand
Which one?
biometrics.
No, you cannot.
I'm saying that backend data.
Yes, so no, the point is what is biometric is basically it takes your biological data from your body and then encodes into some informational system, right? How you do that encoding, right? So it's not immediately readable by a man. That's why it's called the biometric data. There is a that's why the metric comes from. So you take bodily data, and the moment you say it's data, it's quantified. So I am quantifying the features of your body. In a digital space, how you quantify? In bits, right? It's a combination of 0 and 1, right? Am I correct? Right? So that's what pretty much simply it's mean for interdisciplinary crowd, that what are the different types of data that exist, the semi-structured, the structured and the unstructured. Now what happens, we have now, why we are talking about all these things, right? Why we are, this kind of data that we are talking about, right? So what has changed for us to talk about, to be able to talk about all these things in the same environment, right? Everybody understands what is relational database? No? Okay. So, anybody from CS want to take a attempt? Relational database. Look, anybody who has a background?
I am a computer science professor.
Yes. You want to explain what is relational database?
Actually, three data models: hierarchical, relational, network, hierarchical, relational. The oldest is hierarchical, next is network. The recent is relational.
Okay.
Relation means table. Relational database, obviously it is in terms of tables. It has got terminologies like field, record, table. A field is also called as column. Column or field. Row or record. And field is also called an attribute. So a collection of tables constitute the relational database model.
Okay. And why do we, what's the value of a relational database?
What do you mean by relation? Value?
Value in the sense that why would you use? What's the importance, the use value, how you use it?
Easily be reorganized as and when we
Keys are there, various keys are there.
So you can run?
reorganize the data as and when we need it, the way we need it.
Okay. So everybody understands what is relational database? If not, please raise your hand. If you need more explanation, it's fine. You need more explanation?
More recent things like semantic database are there, but still RDB is little older compared to semantic or other databases.
Yes. So I agree with you. I'll come to that in a bit. So a relational database is something, okay, let's say, let me try and put it in a very simple example. Let's say you have lots of, your exams are over, you have the whole semester full of notes, right, which are in physical form somewhere, like papers that you take notes, right, all of you are taking notes now, right, and you have certain ways to mark that which class or which course these notes belong to, and you are trying to organize at the end of the semester, right. So, you have got different file boxes and you want to put these papers into some categories to organize. Now, when you try and do that, so you have created these labels, right. So, this is course 1, this is course 2, this is course 3, right. Now, when you try and organize all your scattered notes and papers according to these boxes, you realize that you can't make a decision which box this particular piece of paper should go to. You feel like, oh, this can go to box 1, but it can also go to box 2, right. Now, what do? So, you create a marker, that is what he was talking about, that you create attributes through which you can say that, okay, I am putting it here, but if I need, I can also use it for 2. So, you can reorganize your organizing your database in a way that depending on your need, right, you can run a query and get these data in the particular function that you need, right, task that you need to perform. On the basis of that, you can recall these data or recall these papers, right. Does that, yeah.
So in essence, there is a, like he was mentioning, right, the fields.
Yes.
There's a predefined
Exactly.
mechanism or a schema, whatever you want to call it, in RDBMS. But let's say, for example, it's a Hadoop or a big data cluster. There is.
Yeah, so that will come to. Yes, we'll come to that. So I just, for people who do not have a background on all these terms, I just wanted to make it clear that what do we mean by when we are talking about relational database. So now going to yes.
Let me see if I can explain this with an analogy. So let's say you walk into a supermarket. So you have all the aisles are labeled, numbered, and you have goods and products based on each category, whatever it is, toiletry or food or whatever it is. But when you walk into a warehouse, you will still have maybe an RFID on each or some labeling or number.
Yes.
But to an average common person in a large warehouse, which the same retailer is talking, you will have no idea.
Yes.
But they, because of using the RFID and some of the labels they have for each, say, row or aisle, they have way
to locate them.
Make sense
Yes.
of it and organize it, right?
Yes.
Right next to a set of books, there may be a Coke bottle.
Exactly.
But this is how Amazon does it. So to us it makes no sense, but to them it's all sorted.
Yes.
So again, a supermarket aisle, in closest example, one RDBMS, a large retailer warehouse, Amazon warehouse, Flipkart, whatever it is, where it's massive, but it's completely, it looks unorganized. It's probably more of a big data.
Yeah.
Analogy, maybe.
Yeah, no, I think it's a good analogy. So, relational database is something which made this, the relationships possible between different categories of data, right. So, you not only categorize them as some predetermined levels, but you also create relationship between these levels. Because these levels are not always, you realize when you try to use this data, these categories are not watertight compartments, right. So, there are overlaps between these categories, and in order for these overlaps to make sense, for you to be able to use the data that you have gathered, so that you create relationship between these categories, right. So, that is in very simplistic term. I am sorry, I am putting it in a very simplistic way. There is a lot of complicated mechanisms that go behind organizing this relational database, but that is what it means, like that is what it does. Now, what happens, as again I am going back to the previous slides, now when you are creating this all these data, right, and the exabytes, the volume that we are talking about, what happens, a relational database is not efficiently able to integrate all these data, right. So, then we are moving to something called distributed databases. So, you are pretty much saying rather than keeping it in one table, you are breaking the data into small parts and distributing it, right. And that is something, has anybody heard of Google file system? So, that is one of the ways, examples of distributed databases. Yes.
This Hadoop is meant for big data. So does it mean that Hadoop should invariably be distributed database only, or?
So Hadoop can be both. Hadoop can be in the distributed. I'll come to that. Just stay with me. We'll explain. This whole slide is about that. So when you are doing this, so you basically so Google file system is one way of doing that. So you try and integrate all that data that is being generated, let's say on a Google search page. You are trying to distribute it in a way so that you integrate. You can basically, what the relational database was trying to see, that create these relations and understand these relations in a more effective way. You could not do it in this management system anymore, so you are moving to a distributed system. Now Google file system is one example which is proprietary. Hadoop is something which is open source platform, right. So other people can come to Hadoop and tweak it. That is what a platform would mean, that tweak it based on their need, right. So now Hadoop or something like a distributed database system might exist in a cluster in a center sort of a environment. It can also exist in a cloud, right. So what then happens that sorry, what does it mean when you move from here to here? So if you do it in a sort of a clustered way and if you move it to a cloud, why do we need to move it to a cloud? Hadoop is an open source platform which basically then hosts all these data. So for example, Yahoo, and it is distributed, so it has multiple nodes in multiple places, right. So like Facebook use Hadoop, Yahoo use Hadoop, the many other big players use Hadoop. So why do we need to move to the cloud? What do we gain?
It can be accessed anywhere.
That is also distributed. So distributed database management is the key here, right. So that can be done in a clustered environment and in a cloud environment, both, right. And in both the environment it can be accessed. Sorry.
What's the difference of what exactly is the distributed database?
So you are basically now breaking the data into smaller chunks, right, and storing it in different places. You do not have a centralized database system anymore. So this is the logic in which the database is organized, the distributed database. It can be hosted in a cluster environment, it can be hosted in a cloud environment, right.
If we can go to an example
Yes.
where distributed database is compulsory, that is more much simplified in understanding. I mean, but for distributed database, the data cannot be stored. Any such example?
Yes, I will come to that. So the distributed, the difference between the relational to the distributed is that there is no logical difference between storing and computing anymore. So storing and computing, these two functions are sort of merged. Does that make sense? No? So here you store the data, that is the database that you are storing it, right. And when you have run a query, that is when you compute the data. Here this is possible simultaneously. So the storing and computing can go on together simultaneously. No? Okay. Ask me, what doesn't make sense? Where is it unclear?
Like there will be times when So not running computations or anything, it just has to sit there.
Yes, it's not what you can, what you do. It is about what it enables you to do. Yes, of course. So this is a evolution, right? So we move from RDMS to a distributed. Yes. If that simplifies what you mean, of course, that would be something. Yes.
Then how will be the retrieval from RDBs?
It's not retrieval. So we have moved on from that to this. That's the analogy he was giving, right? That in a supermarket and the warehouse, right? So as you increase the volume, a supermarket is much contained space, right? You could operate with that RDMS. Because the tables that you have, columns that you have created in your table, just think about the supermarket in a table form, right? So there are finite numbers of columns that you have created, and so there are finite numbers of relations that you can create between these columns. Now when you go to a warehouse, which is 10 times bigger than that, the volume has increased exponentially. So you cannot operate with that. You can, but it will be a very inefficient way of doing it, right? So it's the volume of the data and your need to relate the data, to integrate and aggregate different data columns that makes you move from RDMS to distributed. Does that make sense? So what happens, so first there is a storage thing that you are solving by moving, that now you have broken it down so you can store a large volume. Functionally speaking, what he mentioned, now you can also not only store but compute at the same time in this database system. Now this can happen in a structured, in a cluster environment. The same logic can run on a cloud environment, right? So who are the big players in cloud, like Amazon Web Services? So whatever you do, right, all that data that you're doing, generating through using your smartphones. So these are the biggest players, Amazon Web Services, Azure and Google Cloud. So they basically hold, like 3 of them together, store 100% of the data, that the volume that we saw, that 40% of the data that is generated reside in the cloud. So that 40% is these 3. Okay? Shall we move on?
What's the difference between a cluster environment and a cloud environment?
So cluster environment means that I can have the distributed database, but all of it can reside in, let's say, Electronic City. So there is still a physical angle to it, yes. In a cloud you don't need that. So what is happening, it is becoming more and more virtual when you are moving to a cloud platform. Yes.
To understand what is the politics of it, like
That will come to later. First we are focusing on the material aspect of it. How does it work? Because not all of us in the room understand how exactly it works, right? So let us get a hang on how technically it works. We will come to the politics of it. That is the next part of the presentation.